Welcome to the 6th lecture of this mechanical and electrical systems of mining machines. This lecture is a tutorial on belt drive. This is a part of module 1, that is fundamentals of mechanical systems in mining machines. So, this tutorial we are doing after the lectures on belt, rope and chain drive. Now, we would be solving 3 questions in this tutorial that will be on the belt drive. So, the first question that we would be covering in this tutorial is on a belt drive where the power is getting transmitted from one shaft to another intermediate shaft, then to the final driven shaft. So, the question here is as such: an engine which is running at 150 rpm drives a line shaft by means of a belt. So, this is the engine shaft and this is the line shaft, and then there is a third shaft which is the driven or the dynamo shaft. Now, this engine shaft is running at an rpm of 150 rpm. Now, the engine pulley is 750 mm diameter and the pulley on the line shaft is of 450 mm. That is the diameter of the pulley that is on the line shaft, and on to this pulley which is 450 mm, the pulley which is on the engine shaft is engaged through a belt. Now, a 900 mm diameter pulley on the line shaft drives a 150 mm diameter pulley kit to a dynamo shaft. Now, on the same line shaft there is another pulley which is of 900 mm which is driving a dynamo shaft where a pulley of 150 mm is housed. So, now what we have to do? We have to find the speed of the dynamo shaft when there is no slip and when there is a slip of 2% at each drive. So, this is one drive when the power is getting transmitted from engine shaft to line shaft, and then there is from 900 mm to 150 mm from line shaft to dynamo shaft. This is the another drive. So, the first case is when there is no slip, we have to find how much is the final speed of the dynamo shaft, and when there is a slip of 2% at each drive, that is from engine to line shaft and from line shaft to dynamo shaft, then what is the speed of the dynamo shaft. So, let us try to solve this problem. Now, coming to the solution. So, what we have? We have N1 is equal to 150 rpm. So, here this is, let us say this is D1, this is D2, this is D3 and this is D4. Now, my N1 is 150 rpm. So, D1 is 750 mm. Now, my D2 is 450 mm. So, what do we know? That pi D1 N1 is equal to pi D2 N2. So, this gives me N1 by N2 is equal to D2 by D1. So, here we know what is my N1. My N1 is 150 rpm. What is my N2? We don't know that. And now, what is my D2? My D2 is 450 and my what is my D1? It is 750. Well, this is the expression of N2. My N2 is how much? My N2 is 150 multiplied by 750 divided by 450 rpm. So, this is my N2 expression. Now, when I deal with N3 and N4, so my N3 by N4 will be equal to D4 by D3. Using this same expression, we do pi D3 N3 is equal to pi D4 N4. So, we get this expression where we know that my N3 will be equal to N2. My N3 will be equal to N2 since this is on the line shaft. So, the shaft will have only single RPM. So, that is why my N3 is equal to N2. So, here instead of N3, I put the value of 150 into 750 by 450 divided by N4 is equal to D4. What is my D4? It is 150 divided by what is my D3? It is 900. So, finally, my N4 is how much? It is 150 into 750 into 900 divided by 150 into 450. So, this gets cancelled out, this is 2. So, my N4 is 1500 RPM. And how did we arrive at this answer? When there is my N4 is equal to 1500 RPM, when there is no slippage, right. So, this is my answer 1. Now, when we have to find the speed of the dynamo shaft when there is a slip at each drive, that is when there is a slippage from engine shaft to the line shaft. So, there is a slippage of S1 percentage, that is 2%, and when there is a power transmission from the line shaft to the dynamo shaft, then again there is a slippage of S2 percentage, that is S2 that is 2%. Now, how do we find what is the speed of the dynamo shaft when there is a slippage from engine shaft to the line shaft and from line shaft to the dynamo shaft? Well, our equation comes down here as pi d1 n1 minus pi d1 n1 S1 by 100. What do we understand? That we have a slippage at the engine shaft. So, that is why we are subtracting this length of the time over which this belt that would move over this engine shaft from this time duration. So, our velocity is reduced by this much percentage, where we tell it as again is equal to pi d2 n2. So, this gives us the equation as d1 n1 1 minus S1 by 100 is equal to d2 n2. Similarly, we have pi d3 n3 minus pi d3 n3 S2 by 100 is equal to pi d4 n4. So, what do we understand here? That there is a slippage at this pulley, that is on the line shaft, when the power is getting transmitted from your line shaft to your dynamo shaft. So, now we can directly write the equation as d3 n3 1 minus S2 by 100 is equal to d4 n4. So, this side it gives us the final equation as n2 by n1 is equal to d1 by d2 1 minus S1 by 100. And here our equation becomes n4 by n3 is equal to d3 by d4 1 minus S2 by 100. Now, we multiply the LHS of this equation with the LHS of this equation and RHS of this equation with the RHS of this equation. So finally our equation looks like N2 by N1 multiplied by N4 by N3 is equal to D1 multiplied with D3 by D2 multiplied with D4 1 minus S1 by 100 multiplied with 1 minus S2 by 100. Here our N2 is equal to N3. So finally our N4 is equal to D1 multiplied with D3. So what is our D1? D1 is 750 multiplied with D3, that is 900, divided by 450 multiplied with 150. So this is 2 times and this is 3. So this is this comes down to 6, and then we have 1 minus 2 by 100 multiplied with 1 minus 2 by 100. So this finally comes down to, here we have N1. So this finally comes down to N4 is equal to 150, that is our N1 multiplied with 9.6, which is equal to 1440 RPM. So this is our final speed of the dynamo shaft with slip of 2% at each drive. Now if we see the speed of the dynamo shaft without slippage is 1500 RPM, which has reduced down to 1440 RPM when there is a slip of 2% at each drive. Now coming to the question number 2. Now this is a problem of a stepped pulley. Here what do we see? That we have a shaft, we have a driving shaft and we have a driven shaft, and on both the shafts we have 2 cone pulleys which now helps in transmission of the power through a belt which is shifted from one set of pulleys that are attached with each other. We understand that the length of the belt which is to be shifted from one set of the pulley to the other does not change. So now coming to the question, it tells a shaft which rotates at a constant speed of 160 RPM. Now we have a shaft which is constantly rotating at 160 RPM, is connected by belting to a parallel shaft of which is 720 mm apart. So the distance between these two shafts is 750 mm. Let us take it as x, which has to run at 60, 80 and 100 RPM. Okay, so now we have 3 speeds with which my driven shaft would be rotating, that is 60, 80 and 100 RPM. Now the smallest pulley on the driving shaft is 40 mm. So on the driving shaft I have a smallest pulley which is R1. My R1 is 40 mm radius, and what we have to do, we have to determine the remaining radii of the 2 stepped pulley for a cross belt and an open belt. So what we have to determine, we have to determine the radius R2, R4, R6 and R3 and R5 in this question. So there are 2 conditions, one is a cross belt drive and one is a open belt drive, and what we have to do, we have to neglect the belt thickness and slip. So what do we understand? That T is assumed to be 0 and my slip is also 0. So here my N1 which is equal to N3 which is equal to N5, it is given as 160 RPM. My X is given as 720 mm and my R1 is given as 40 mm. Apart from that, I also have my N2 which is given as 60 RPM, my N4 is given as 80 RPM, N6 is given as 100 RPM. So, the first case, what we know is for the set of pulley, that is N1 and N2. So, here we know what is N1 is known, N2 is known and R1 is also known. So, by taking the velocity ratio, that is N2 by N1 is equal to R1 by R2, we can determine what will be R2. So, my R2 is equal to R1 times N1 by N2. So, which is equal to 40 times 160 divided by 60, which gives me 106.7 mm. You can use your calculator to get this value. Now, again, what do I see is for my second set of pulley, that is N3 and N4. So, my N4 by N3 is equal to R3 by R4. So, this gives me my R4 is equal to R3 multiplied by N3 by N4. So, my R3 is equal to how much? So, my R4 is equal to R3 multiplied with 160 by 80, which is equal to 2 times of R3. So, my R4 here is 2 times of R3. However, we have another relation with respect to the distance between the two shafts, that is my R1 plus R2, we know my R1 plus R2 is equal to R3 plus R4 is equal to R5 plus R6, right. So, this can be given as equal to R1 is 40 plus 106.7, which is 146.7 mm. So, with this expression, we can directly get this relation for R3 and R4. Now, we know that my R4 is 2 times R3. So, we can write R3 plus 2R3 is equal to 146.7 mm. So, this gives me my R3 is equal to 146.7 divided by 3, which is equal to 48.9 mm, right. So, here I can determine my R4 is equal to 2 times of R3, which is equal to 2 multiplied with 4, 48.9, which is 97.8 mm. Now, again, when we do the same procedure with my N5 and N6 pulley. So, this is equal to R6 by R5. So this gives me my R6 is equal to R5 multiplied with N5 by N6, which is equal to R5 multiplied with 160 by 100, which is equal to 1.6 R5. So my R6 is 1.6 time of R5. So now R5 plus 1.6 of R5 will be equal to 146.7 mm. So this gives me R5 is equal to 146.7 divided by 2.6, which is equal to 56.4 mm. Now my R6 will be equal to 1.6 times of 56.4, which is equal to 90.2 mm. So this we could find the relation of all the radius in a cross belt drive. Now for a open belt drive, we have N2 by N1 is equal to R1 by R2. So this gives me my R2 is equal to R1 multiplied by N1 by N2, which is equal to 40 multiplied by 160 by 60, which is equal to 106.7 mm. So in the same way, my N4 by N3 is equal to R3 by R4. So this gives me my R4 is equal to R3 times N3 by N4, which is equal to R3 multiplied with 160 by 80, which is equal to 2 R3. So for open belt drive, what we know that my L is equal to pi R1 plus R2 plus R2 minus R1 square by x plus 2x. So my L is equal to pi 40 plus 106.7 plus 106.7 minus 40 square divided by 720 plus 2 multiplied by 2 into 720. So here my R1 is 40, my R2 is 106.7, my X is 720. So this gives me a relation of L is equal to 1907 mm. So what we understand that this length of the belt is constant even though it is meshed with any set of pulley. So this expression can now be written as, now my 1907 is equal to pi R3 plus R4 plus R4 minus R3 square by x plus 2x. So this gives me a relation of pi R3 plus 2R3 plus my R4 is 2R3 minus R3 square by x plus 2 into 720. So this gives me an equation of 9.426 R3 plus 0.0014 R3 square plus 1440 is equal to 1907. Now, when we solve this equation, 0.0014 R3 square plus 9.426 R3 minus 467 is equal to 0. So, this gives me, after solving, my R3 is equal to 49.3 mm and my R4 is equal to 2 R3, which is equal to 98.6 mm. So, similarly, we have N6 by N5, which is equal to R5 by R6, which gives me my R6 is equal to R5 times N5 by N6, which is equal to R5 times 160 by 100, which is equal to 1.6 R5. So, the same equation we put it here, where we get 1907 is equal to pi R5 plus R6 plus R6 minus R5 square by x plus 2x, which can be written as pi R5 plus 1.6 R5 plus 1.6 R5 minus R5 square by 720 plus 2 into 720. So, this equation boils down to 0.0005 R5 square plus 8.17 R5 minus 467 is equal to 0. So, this gives us R5 is equal to 60 mm and my R6 is equal to 96 mm. So, in this way we can get the length of the radius for each of the pulley in this stepped pulley, and we can get it for cross belt and for open belt with the following procedure. Now, coming to the third question, where we have two pulleys in which we have one 450 mm diameter and the other is 200 mm diameter, which are on parallel shafts, and now the distance between these two shafts is given by 1.95 meter apart and are connected by a cross belt. Now, we have to find the length of the belt that is required. First is the length of the belt required, and the second is the angle of contact between the belt and each pulley. This is number 2. And the third is what power can be transmitted by the belt when the larger pulley rotates at 200 rpm, if the maximum permissible tension in the belt is 1 kilonewton and the coefficient of friction between the belt and the pulley is 0.5. Now, coming to the solution, what we have D1 is 450 mm and my D2 is 200 mm. So, this we can write as 0.45 meters, and all this also we can write as 0.2 meters. So, here R1 we can write it as directly, since we are finding the length of the belt where we want R1 and R2. So, my R1 is 0.225 meters, here my R2 is 0.1 meters. Now, I have X which is 1.95 meter, N1 is given as 200 RPM and my T1 is also given as 1 kilonewton, which is we can write as 1000 Newton, and it is also given mu is equal to 0.25. Now, how do we know what is the speed of the belt? Now, speed of the belt, first we find the speed of the belt. So, it is V is equal to pi d1 n1 by 60, which is equal to pi multiplied by 0.45 into 200 divided by 60, which is equal to 4.714 meter per second. Now, for cross belt, crossed belt, we know my L is equal to pi R1 plus R2 plus 2x plus R1 plus R2 square by x. So, this gives pi 0.225 plus 0.1 plus 2 multiplied with 1.95 plus 0.225 plus 0.1 square by 1.95, which gives me the value of 4.975 meter. Now, when we talk about the angle of contact between the belt and each pulley, so it is given by theta. So, here for crossed belt drive, so we know that theta is equal to the angle of contact between the belt and the pulley. So, my sin alpha is given as R1 plus R2 by x, which is equal to 0.225 plus 0.1 by 1.95. So, which is equal to 0.1667. So, this gives me my alpha is equal to 9.6 degree. So, from here we can find my theta is equal to 180 degree plus 2 alpha, which is equal to 180 degree plus 2 into 9.6 degree, which is equal to 199.2 degree. Now, in radian if I have to find, it is 192 into pi by 180, which gives me 3.477 rad. So, this gives me my second answer. So, my first answer is given herein, which is the length of the belt in a cross drive, and this is my theta, which is given as 3.477 rad. Well, when we have to find the power that is transmitted by the belt, how do we find that? First, we have to find the tension. We know for number 3, we know the power that needs to be transmitted is P is equal to T1 minus T2 multiplied with V. So, here T1 we know, V we know, how to find T2. So, we have this expression of 2.3 log T1 by T2 is equal to mu theta, which is equal to 0.25 multiplied with 3.477. So, which is equal to 0.8692. So, if I find log T1 by T2 is equal to 0.8692 divided by 2.3, which is equal to 0.378, and my T1 by T2, if I take exponent of 0.378, it is 2.387. So, this gives me my T2 is equal to T1 by 2.387, which is equal to 1000 by 2.387, which is given by 419 Newton. So, my P is equal to T1 minus T2 multiplied with V, which is given by 1000 minus 419 multiplied with V. What is my V? It is 4.714, which gives me 2740 watt, which is equal to 2.74 kilowatt. So, with this we have completed 3 different kinds of problem that we would be able to solve for the belt drive. So, in next class we will be starting with gears. If you have any problem or you have any doubt, you can refer to this book Khurmi and Gupta, Theory of Machines. So, these are the example problems directly from these books, and there are many questions that are given in its exercise. I strongly recommend you to kindly solve them. Thank you.